Welcome to a lesson with Dr. Powell. Let's take a look at the derivatives of trig functions. We already know that the derivative of sine is cosine, and the derivative of cosine, so d dx, say, okay, cosine is negative sine. Okay, but let's look at the other ones. We still have 4 other basic trig functions to look through. First, maybe let's do cosecant, because that's 1 over sine. Okay, so cosecant is cosecant x, and we're going to take the derivative of this. Just think of it as 1 over sine, or sine to the negative 1. So to take the derivative of this, we have a composition, right? So we have this idea composed with that idea, where you're plugging this into that. So taking a derivative of this is negative, it's a negative 2, multiplied by the derivative of this, which is cosine x, but then you plug what this was into the derivative itself, sine x, there's your derivative. So this would be negative cosine x all over sine squared x. Well, let's rewrite this, all right, a little bit. We can think of this as being equal to negative 1 over sine x times cosine x over sine. This part right here is the cotangent of x. This part right here is negative cosecant x. So we can add to our list here. Cosecant x becomes negative cosecant x, cotangent x when we take a derivative. All right. Let's look at another one, but just remember what these were. Okay. Let's look at the derivative of secant now. So this is 1 over cosine. So we can think about taking the derivative of cosine x raised to the negative 1 power. Thinking of the same technique here, we're taking the derivative of this composed with cosine x, and we're going to end up being getting negative, it's a negative 2, but plugging that into it, but then multiplying the composition there, negative sine x. So we end up getting this, which we can rewrite as positive sine x over cosine squared, but I'll split the cosine squared into 2 parts and do that. So it looks like we'll actually end up getting secant x tangent x. So this right here is the derivative of secant x. Okay, let's look at another one. Tangent x. Tangent x is sine x divided by cosine x. We could use a boxing technique, a product rule in some way, but we could do a quotient rule too. So let's practice that. All right, sine x, cosine x, sine x, cosine x. This one gets the turn. This one gets the turn. When the bottom gets the turn, there's a minus all over the bottom squared. Derivative of this is just cosine, so we end up getting cosine squared. Derivative of cosine x is negative sine, so we have a negative negative, so plus, so we end up getting plus sine squared all over cosine squared. Notice that there's an identity. This is equal to 1. So we end up getting 1 over cosine squared. Another way of writing that is the secant squared. So that means that the derivative of tangent of x is equal to the secant squared of x. Okay, let's look at cotangent now. The derivative of cotangent x is equal to cosine x all over sine x. Think of the quotient rule again. So we'll do that. We'll do, so we'll do cosine x, sine x, cosine x, sine x. When this guy, so they take turns being a derivative, minus all over sine squared. Now in this case, let's see, derivative of cosine is negative sine. So we end up getting a negative sine squared here. Over here, derivative of sine is just positive cosine multiplied by that. So it's just minus cosine squared. Okay, so the top looks like negative sine squared x plus cosine squared x. So it looks like the top is just equal to negative 1. So we get negative 1 over sine squared, which is the same as negative cosecant squared x. So that means that the derivative of cotangent is negative cosecant squared x. Let's go through these and just recall what's happening. So the derivative of cosine is negative sine. The derivative of cotangent is negative cosecant squared x. Derivative of cosecant x, derivative arrow here, is negative cosecant x cotangent x. Now, actually, if we now move to sine, tangent, and secant, notice something very similar. Cosine x, secant squared x, secant x, tangent x. Notice, at least for these, there's no cos at all in the result. But for all of these, we have plus every time. Only when we have the cos are there negatives. Also notice, sine of x is cosine. The just kind of the co-pair of this would be sine. Cosecant, the co-pair is that's kind of a funny term, co-pair, but just kind of secant, cosecant, right? So so what's the other co thing is cosecant here. You just take cos of those. So secant tangent and cosecant cotangent. So there's a lot of ways you can kind of maneuver through this to memorize these. I recommend memorizing all of these and finding mnemonics to know these, because it'll make life easier when you're taking large derivatives. If you don't have to look them up, or you can just know them. So that is my recommendation. Thanks for watching.